Hello guys, welcome once again to the Logic Talks. In this session, we will be discussing about the Myhill Nerode Theorem for minimizing DFA. The minimization here means to reduce the number of states of a given DFA to the minimum possible, with the condition that it accept the same language which was accepted by unminimized DFA. So let us directly jump on to the question. So the question is to apply Myhill Nerode theorem to minimize the given DFA. So the DFA may be given in the form of a transition table, or it may be given in the form of a transition diagram, one and the same thing. So the minimization here means to reduce the number of states to the minimum possible without having any change in the language which is accepted by the DFA. So now let us move on to the solution. So the first step is to construct a matrix of size 6 by 6. 6 by 6 because here we are having 6 number of states Q0, Q1, Q2, Q3, Q4 and Q5. Therefore, we will be having a matrix of size 6 by 6. And yes, here we only need to consider the lower left half of the matrix, that is below the diagonal, and even we will be excluding the diagonal also. So here in this matrix we will be considering only the part that is colored in blue, only the cells which are colored in blue. So now the second step is to mark all the cells where one of the states is final and other state is non-final. So here as we can see, if we talk about this Q1, Q0, so this cell, now we have to check here, Q0 is the non-final state and Q1 is also a non-final state. So therefore we will not mark this cell. Next, coming on to Q2, Q0, this cell. So here we can see that Q2 is a non-final state and Q0 is also a non-final state. So therefore, we will also not mark this cell. Next we are having is Q2, Q1. Here we can see that Q2 is a non-final and also Q1 is also a non-final. Therefore, this cell will also not be marked. Next we are having Q3, Q0. Here we can see that Q3 is a final state and Q0 is a non-final state. Therefore, since one of the state is final and other is non-final, therefore it is marked. And now again for Q3, Q1, again Q3 is the final state, Q1 is the non-final state, so therefore this cell will also be marked. Again for Q3, Q2, we are having Q3 is the final state and Q2 is a non-final state. Therefore, this cell is also marked. Now coming on to the next Q4, Q0, Q4 is the final state, Q0 is the non-final state. Therefore, this is also marked. For Q4, Q1, Q4 is the final, Q1 is a non-final, therefore it is marked. Then coming on to Q4, Q2, Q4 is the final, Q2 is non-final, therefore it is also marked. Now coming on to Q4, Q3. Here in this case, Q4 is the final and Q3 is also a final state. Therefore, this cell will not be marked. Whenever we are having both the states either as final or both the states as non-final, that cell will not be marked. So in this case, again we will be checking for Q5, Q0. Again, Q5 is a non-final state, Q0 is a non-final state, therefore not marked. Again, Q5, Q1, Q5 is a non-final state, Q1 is a non-final state, again not marked. Q5, Q2, Q5 is non-final, Q2 is non-final, therefore not marked. Again, Q5, Q3, Q5 is non-final, Q3 is final, therefore marked. Next we are having Q5, Q4, Q5 is non-final, Q4 is final, therefore it is also marked. So this is what we will be doing in the step number 2. Now we have to consider the unmarked cells one by one and determine the transitions of both the states associated with the cell for each of the input value. For example, let us now see for the cell Q1, Q0 or Q0, Q1. See here, Q0 on getting 0 as input is moving to state Q1, and Q1 on getting 0 as input it is moving on state Q3, and Q0 on getting 1 as input is moving on to state Q2, and Q1 on getting 1 as input is moving on state Q5. So here we can see that we are getting Q1, Q3 and Q2, Q5 as a result of the transitions on Q0, Q1. Now see the resultants of these transitions very carefully. We are having Q1, Q3, one pair, Q2, Q5, another pair. Now we have to see in the table again if Q1, Q3 is marked or not. Q1, Q3 is marked or not. Yes, Q1, Q3 is marked. If any of the pair is marked, either Q1, Q3 or Q2, Q5, then we also have to mark Q0, Q1. Next, we will be considering another unmarked cell, that is Q2, Q0 or Q0, Q2. So for this, again, we will be checking the same. Q0 on getting 0 as input is moving to state Q1, and Q0 on getting 1 as input is moving to state Q2, and Q2 on getting 0 as input is moving to state Q5, and Q2 on getting 1 as input is moving to state Q4. Again, we will be checking these pairs Q1, Q5 and Q2, Q4. We will check in this table Q1, Q5, Q1, Q5, Q1, Q5. This is unmarked. Okay, no problem. Then we are having Q2, Q4, Q2, Q4. This is marked. Therefore, we also need to mark Q0, Q2. Now again, we will be checking the cell Q2, Q1 or Q1, Q2. This one. So here again, Q1 on getting 0 as input is moving to state Q3, Q1 on getting 1 as input is moving to state Q5, Q2 on getting 0 as input is moving to state Q5, Q2 on getting 1 as input is moving to state Q4. So again, we will be checking Q3, Q5 in the table. Q3, Q5, Q3, Q5, Q3, Q5. Yes, Q3, Q5 is marked. Therefore, we also have to mark this cell Q2, Q1. So this is also marked now. So now let us move on to another unmarked cell, that is Q4, Q3. So again, let us see for Q4, Q3. Again, Q4 on getting 0 as input is moving to state Q4. Q4 on getting 1 as input is moving to state Q4. Q3 on 0 input, it is moving to state Q3. Q3 on 1 input is moving to state Q3. So again, now we will be checking Q4, Q3. Q4, Q3, this one. Again, this is unmarked. And again, next is Q4, Q3. Again, this is unmarked. So now let us move on to the next unmarked cell, that is Q5, Q0 or Q0, Q5. So here as we can see that Q0 on getting 0 as input is moving to state Q1. Q0 on getting 1 as input is moving to state Q2. Q5 on getting 0 as input is moving to state Q5. Q5 on getting 1 as input is moving to state Q5. So here we are having Q1, Q5 and Q2, Q5. Let us again check them in the matrix. Q1, Q5, Q1, Q5. Again, unmarked. So leave it. Q2, Q5, Q2, Q5. Again, unmarked. Therefore, we will not be marking this cell right now. Let us move on to the next cell, that is Q1, Q5, Q1, Q5. So again, we will be checking the transition Q3, Q5. So check here. Q3, Q5. Yes, it is marked. Therefore, we will be marking this cell also. So now let us move on to the next cell, that is Q5, Q2 or Q2, Q5. So here as we can see, Q2, Q5, on 0 transition it is giving me Q5, Q5, and on 1 transition it is giving me Q4, Q5. So now let us check Q5, Q5. It was not considered, so leave it. Q4, Q5, Q4, Q5. Yes, this one, Q4, Q5. It is marked. Therefore, Q2, Q5 will also be marked. This is what we are having in the first iteration. And now we have to repeat this process. And the process will be repeated until we stop getting any changes in this table. Now again, we will consider these unmarked cells and we'll see if there are any changes in the matrix. So first is Q4, Q3 or Q3, Q4. So let us see that. Q4, Q3 on 0 input is giving me Q4, Q3, and on 1 input is giving me Q4, Q3. So again the same cell, and it is unmarked, so this will remain unmarked only. Next unmarked cell is Q5, Q0 or Q0, Q5, this one. So again it is giving me Q1, Q5 on 0 input and Q2, Q5 on 1 input. Let me check Q1, Q5, Q1, Q5. Yes, it is marked. Therefore, I will also mark this state. So this is what we are having, the final matrix. And the main point of concern is the cell which was left unmarked. This is the one that was left unmarked, and it is associated with the states Q3 and Q4. So basically, these two are the states Q3, Q4 that need to be merged into one. Okay, so we will be merging these two states now. So in merging, what we have to do, let us see, we are having these two states that are to be merged. So we will just merge them like this, Q3, Q4, Q3, Q4. Means both these rows will be merged, Q3, Q4, Q3, Q4, Q3, Q4. Okay, merged. And wherever you are finding Q3 written here, either Q3 or Q4 in any other transition, so that will be replaced with Q3, Q4. Then here you are having Q3, this was replaced with Q3, Q4, and here you are having Q4, this will be replaced with Q3, Q4. So this implies that Q3, Q4 was kind of a redundant state, means it was meaning the same. So this is the state transition diagram that we got after minimizing the given DFA. So we have used Myhill Nerode theorem to minimize the DFA here. So this is our final answer. I hope it is clear to all of you. For more such videos, you can subscribe, like, and share the video. I will be coming with more such videos. See you in the next video. Till then, take care and bye.